Okay, so in this last video, I want to show you how you can connect two programs together, two commands, to make essentially a limitless combination of things that you could process. So kind of the design philosophy of Unix and Linux from that is that each thing it does, each command it provides, does one task very well. Like the cd command is all about changing the directory. It doesn't do other things like on top of that. And so each command is kind of localized to its own thing. Now, that's nice because it gives you a bunch of essentially atoms to work from. You can build these different atoms together to make more complex structures, which is pretty cool. So what I want us to start by doing is I want to look at this fruits.txt file, and I don't want to just see the list of all the berries. I want to get the count, the number of berries in this file. So let me show you one way to do this with what we've learned so far. The trick will be we'll use files to save state. So what I'll do is I'll grep berry fruits.txt and and output that to berries.txt. So that's there. Then I'll just word count -l. The -l command, flag, remember, gives you just the number of lines. And so this will give me the number of lines of berries.txt. So there are 35 berries in that whole file. So this is one of the really nice things about learning about file redirection, is that you can do stuff like this. However, it's really tedious that was essentially two things that we have to do. Three if you want to remove that intermediate file. So they provide, or Bash provides, a way of, in some sense, skipping the middleman. Skip that middle file and just go straight to the output from one program becoming the input for the other. And the way you do this is with the pipe operator. So you can type grep berry fruits.txt pipe wc-l. Okay. This vertical bar we call a pipe. This command is exactly the same as what we did before, where we first save the result of grep to a file and then use word count to read from that file. The only difference is, well, it's not exactly the same. We'll talk about one key difference. But the difference is we're skipping that file creation. It's just taking the output from grep and making it the input for word count. Now, when I type this, it just runs. Now, let me highlight one key difference, how these things aren't the same. Remember the way I just showed you before this, we'd use word count -l berries.txt. Now, think about this for a second. Is this getting the berries from standard in or an argument? Here in this old command, it's an argument because I passed it into the command line. But now when I'm using this pipe, it's becoming standard in. The only way this works is because, and I didn't tell you this, word count, like grep, knows to read from standard in if it's not given any file arguments. And so you could do things like A, C, B, D, something like that. Hit stop and it prints out how many lines. So it got the output of grep as its input, just like I just typed it in, but instead it's whatever the grep outputted, and then it just counted those. So and I hit Control-D to stop there, like I did before. So just remember that that's an important thing, that this piping is all about changing standard out from one program to become standard in for the other. And it's called piping because it's like you're putting a pipe between one program, its output becomes the input of the next. Now, the pipe operator is really important to get right. What do you think would happen if you tried this? Fruits.txt, waka wc, and ignore the -l for just 1 second. Let's just do wc. What does this do? Take a second to think. Before I press enter, what do you think this is going to do? Now, you might think that it's going to call word count, passing this in, but this right waka is all about saving to a file. And so what this is actually going to do, it's going to run, but what it's done is it's created a new file called wc. You can cat it. It's just like any plain old file. It just doesn't have an extension on it. So when you run it like this, it's just saving it to a file called WC. But when you use the pipe, it's saying treat that thing on the right as command and use it as standard, use the output as standard input. Think about it almost like type checking in Java, like how methods have parameters that have particular types. The arrow command, the thing that goes on the left is a command, and then on the right is a file. Same thing with input. You put a command on the left, and then a waka, and then a file on the right. The pipe operator is a command to a command. It takes the standard out from one command to become the standard in of the next. And with that, you now that you know pipe, you have this whole world of possibilities of things you could do, of complex combinations of programs you can use by taking output and chaining it along to the next program's input. So I want us to practice this. This slide here kind of shows you what this pipe command does. Suppose I have a file called berries.txt, where each line is the name of a different berry. What I want you to do is I want you to write a command that outputs how many berries, so the number, how many, of the names that contain both the letter A and the letter E. And they don't have to be next to each other. It's not just AE, but all berries that have both an A and an E in them. So I'm gonna go ahead and pause for a second and let you try this on your own. Okay, so now that you had a chance to try this, let's see how we go about solving this. So here is probably the first thing I would have thought of. It's gonna end up not working, but it's a really good first try. So I'm gonna try grep. And then I'm gonna pass in A and E, and then berries.txt. As I said, we assume there's a file called berries.txt here. This is not gonna quite work because it's gonna say, hey, no such file as E in this directory. And the reason is grep only reads the first argument as the pattern to search for. If you look at grep, it shows you that the first thing it uses is the one pattern. It doesn't take a pattern ... like it does for files, where it takes one or more files, or 0 or more files. So this is not going to quite work. And so now to kind of drive that home, if we look back at our I forgot the .java, our hello world.java, and I print out my arguments, there is a difference between hello world.java A, B, C, which will print out 3 arguments there, versus hello world ABC, where it's just going to print out 1 argument. So the command line, when it's interpreting your command, will treat each quoted string as 1 argument. Whereas if you don't use quotes around the whole thing, it's going to treat those as 3 separate arguments. So this is not going to quite work. And so you might say, well, okay, maybe I can fix this by saying something like AE or A space E. But the problem here is this will only search for the string literal AE. So only some files will show up there, or some berries, and it looks like no berries have AE in them. Okay, so maybe we could try to do this differently. Like, how do I get it to do both this and that? Well, this is where piping starts coming in, where you know how to do one of these tasks, like finding all the berries that contain E and then finding all the berries that contain A. So maybe we could use piping to our advantage. So you might try something like search for A into berries.txt. Hit enter, and it'll show you all the berries that contain A. Now, what you might try next is to pipe that output into grep. So you might say grep E berries.txt. And now it prints out a bunch of stuff. The reason this command is printing out so much is this second command here, the grep E berries.txt, is searching through berries.txt and printing all the things with E. But we don't want it to search through berries.txt. We want it to search in the output from the previous command. So we want to call grep the second time in the way that it reads from standard input. So you want it to read from just the things that were printed from the last grep command. And now we get all the things that contain A, and E. Now, we wanted to find the number of these. So this is going to be the number of lines of this output. And to find the number of lines, use the word count -L, word count -L program. And so there are 13 berries that contain both an A and an E. So again, try to tackle this thing in parts. And the hard thing about this almost always is you have this abstract task, find all berries that contain A and E, and then you need to figure out how to decompose it into small, simpler tasks that you can chain together in order to solve the whole problem. Now I want to show you a couple other applications of piping that are kind of common in not day-to-day tasks, but you use these a lot, especially if you go out into industry, you'll use one of these. So one thing I want to do real quick is for context is find the number of unique fruits in my fruits file. So I can't use wc-l fruits.txt. I mean, I can, but this file actually contains some duplicates. So it's going to overcount the number of unique fruit. So what you want to do is somehow find the unique lines. Thankfully, there is a command called unique, and it reads from standard in and print out all of the unique lines. So A is unique, B is unique, C is unique. Unfortunately, the way unique works, if you type C again, it doesn't print it out. It doesn't keep printing out extra C's because they aren't unique. You press D, it prints it out. So notice the first D was the thing I just typed in, and the second one is the print. The unfortunate thing about unique is it only works on consecutive duplicates. So if I type A again, it's going to print out that A was unique. So it's a very simple program in that it's not looking for global uniqueness. It's just looking for sequences of uniqueness and collapsing all of them. So in order to fix this, we're going to have to start by sorting our file. I'm going to start by sorting fruits.txt and then piping it into unique. And by sorting it first, we put all the duplicates next to each other, and now unique can work properly. And now you can take that output and pipe it into wc-l to get 115 unique fruits, which notice is different. There were about 15 duplicates in fruits originally. One last example I want to show you of cool piping applications. Again, we're going to get lots of practice with piping. So I'm just going to type this one out. Tail-f CSE web courses logs common log pipe grep 391. Okay, it's not doing anything right now. It's okay. What I'm doing is I'm using the tail command, and I'm using it on this special file, CSE web courses logs common logs. This is the CSE server's log file for every time that someone accesses one of the websites. It logs what time and what page was accessed. The -f flag for tail is a kind of special one, and it's one you use commonly in industry when you're trying to monitor something. It gives you a live refresh. So it kind of this program is still running, and it's just constantly spitting out logs. Now, we're not seeing them because we're filtering with grep. So if I took out this pipe here, you'd see a bunch of stuff. And every time someone looks at the website again, it refreshes and shows you more things. But with grep 391, you could do things like find all the times people are looking at the 391 website. So when I go there right now and refresh, you'll see a couple logs pop up here. And so usually this is how a lot of times you might debug something in industry. Someone reports an error, and you have to go look through a bunch of logs and try to figure out what went wrong. And so what we'll actually see later in this course is how you can get fancier for the things you're searching for. So if you know you're searching for a particular URL or a particular pattern, how you can do that in a much fancier way. But I just want to show you that there are lots of applications of this piping. All of them aren't necessarily related, but it's a very universal operation that you'll find yourself using quite frequently. So with that, we've kind of covered everything I want to talk about today. We talked about a bunch of miscellaneous commands, including how to compile and run Java programs. We talked about redirecting input and output to files. And we talked about piping the output from one command to become the input of the next. And so your homework assignment for this week will practice all of these things. Thanks so much, and see you next time.